Okay, so with 15 we have carbon, hydrogen. Okay, so here's the thing. Whenever you have two of something, you're going to put them next to each other for the tetrahedral shape. And the reason for that is if you don't put them next to each other and it could be polar, it's always going to cancel out. So it could affect things if you don't have them next to each other. Now, if you're thinking about like, well, how does it actually exist in real life? If you do it like this, you could turn the molecule to have it so that they're both on one side and then the other side is the other atoms. So you could rotate it so that it works like that. So if you did this and you had them like across, and we had to pretend that this is polar for a second, we would think that it cancels out, but just because they're across from each other, they're actually both, either moving in towards us or moving away from us. So like the three-dimensional shape plays a part. If you don't want to worry about all that stuff, then just keep them next to each other, and then that'll help you figure out the polarity. All right, so let's not do that. Let's do this one. Now with this one, let's check it out. So we have 2.1, we have 2.5, and then this is also 2.5, 2.5, and 2.1. Now here, between the 2.5 here and the 2.1 up here, there is going to be a difference of 0.4. The electrons are moving down towards these iodines. So this is going to be slightly negative. It's going to be slightly polar. This one's going to be slightly positive here. All right? Even though the center is the same as over here, just try to look at like the ends of it and you'll see that there's a difference that works out that way. On the test, I'll try to make it more distinct. I'll try to use something like maybe bromine or something else that's 2.8 or something a little higher there to make it a little bit more obvious. Now the shape of this and everything else we know is AX4, tetrahedral, hybridization is sp3, and it's 109.5 degrees. All right, any questions with that one?